I'll start recording from here. All right, the next problem is another solve the equation. You get the first part and then you get the second part. So they pop up separately. But we're going to solve this equation just like we solve any linear equation. We're going to first remove the parentheses by distributing the 3 across. So I get 3 times x is 3x. 3 times 2 is 6. So on the left-hand side of the equation, I have 3x plus 6. On the right-hand side, I have 2 plus 3x. And what happens when I subtract 3x from both sides to isolate the x terms? Well, I end up with 6 equals 2. And that's nonsense. 6 does not equal 2. So this equation doesn't have a solution. Or the solution is the empty set. And that is true. There is no value of x that you can plug in here and this is going to work. It doesn't exist. So since there's no solution, since what we get doesn't make sense, this is inconsistent. Now, I don't assume that the problem on the test is going to be the same. I mean, I suppose you could get something that's an identity. And what happens when you get an identity? You would get something that's always true, like 6 equals 6, or 2 equals 2, or 3 equals 3, or 4 equals 4. If you get something like that, then the solution set is any real number. Anything will work. And that's an identity. So you could get a solution. So you get x equals a number. That means you got a solution set and it's conditional. So if you have a solution, it's conditional. Or you get something like this that makes no sense. That means it has no solution. The solution set is the empty set and it's inconsistent. Or you get something that's just true, like 2 equals 2. That means that any real number works. So the solution set is the set of all x such that x is a real number, and that's an identity. Those are the 3 possible scenarios you have when solving an equation. Okay, the next problem is a word problem.
You did say we could write our own.
Yes. Yeah.
We were allowed to write on our notes.
Yes. Okay, the next problem is a perimeter problem. Okay, I'm going to draw myself a picture. I like pictures. Rectangular athletic field is twice as long as it is wide. So if I let the width be x, the width is usually the shorter of the 2 sides, then the length is twice as long. Twice means 2 times. So the length is 2x. So it tells me that the perimeter is 216. The perimeter formula is 2 times the width plus 2 times the length. So 2 times my width is 2 times x, plus 2 times my length is 2 times 2x, and that's equal to 216. So 2 times my width plus 2 times my length is my perimeter. So 2x plus 4x is 216. 6x is 216. Divide both sides by 2. And I get x is, take my handy dandy calculator out. And I get x is 36. So the width of my rectangular field is 36. The length is the longer of the 2, and it's twice as long as the width. So 2 times 36 is 72. And you can show yourself that this is true. Add 36 and 72, 36 and 72, and you should get 216. 108 plus 108 is 216. Okay, The next problem is division of complex numbers. To divide complex numbers, we multiply numerator and denominator by the conjugate of the denominator. Since my denominator is 3 minus 6i, the conjugate is 3 plus 6i. And we multiply both the numerator and the denominator by that conjugate. To multiply the numerators, we distribute. We distribute the 7i across the 3. We distribute the 7i across the 6i. 7i times 6i, 7 times 6 is 42. I times I is I squared. The denominator, I'm a lazy so-and-so, so I'm going to multiply that complex number by its conjugate by squaring the two numbers and adding them together. When I multiply a complex number by its conjugate, I get a real number, and it's the sum of the two squares. That's why we do it. So that's 3 squared plus 6 squared. By definition, that's what happens when you multiply a complex number by its conjugate. You take the 3 and you square it, you add to it 6 squared. Okay, so what do we got? I have 21i. I squared by definition is -1. I squared is equal to -1, so I get minus 42. This right here is -1. Divided by 9 plus 36 is at 45. Now we just rewrite this. We put the real part first and the imaginary part second. So we're going to write -42 over 45. Plus 21 over 45i. So we rewrite it, -42 over 45 plus 21 over 45i, and then simplify. What can we do? I think I can divide out a 3. 42 is divisible by 3, as is 45. So 42 divided by 3 is that, what is that? Got it written down somewhere, 14. So I'm going to divide out a 3. So that's going to be -14 over 15. Plus, I can divide out a 3, 7 over 15. So the result is -14 over 15 plus 7 over 15i. And to simplify those two fractions, I divided out a 3 from the numerator and denominator. So 42 divided by 3 is 14. 45 divided by 3 is 15. So -42 45ths is the same as -14 15ths. 21 over 45, I can divide numerator and denominator by a 3. I could cancel a 3. 21 divided by 3 is 7. 45 divided by 3 is 15. Okay, problem 7 tells you to do this by factoring. I don't care. Now, you probably should practice factoring and not rely on the quadratic formula for everything. But the fact of the matter is the quadratic formula will solve this. When I was factoring this yesterday, I have a 16 x squared. So I need in my first places I need two things that will multiply and give me 16 x squared. And when I thought about this, I thought, well, it's not going to be 4 and 4. I bet you dollars to donuts it's not 4 and 4. And I bet you it's not going to be 16 and 1. I think it's probably going to be 8 and 2. And that is truly a gut feeling on my part. Okay. So then I need to put in place in the last places two numbers that are multiplied to -3. And then when I FOIL it, when I get outside plus inside, I get 2. So I'm probably not going to put the 3 there. That's probably not where I'm going to put it, because then I would have 24 and 2. So that's not going to work. So I'm probably going to put the 3 right there and the 1 right there. And now outside and inside, I've got a 6x and an 8x. And the difference between 8 and 6 is 2. So if I put a plus here and a minus there, I think I got it. Now let's make sure that FOILs to 16x squared plus 2x minus 3. So first, 8x times 2x, 8 times 2 is 16, x times x is x squared. Outside is plus 8x, inside is minus 6x. 8 minus 6 is 2, 2x. Last, minus 3 times plus 1 is minus 3. So that is the factorization of that trinomial. So now, to solve this, I set each factor equal to 0. So I take the 8x minus 3, and I set that equal to 0, and the 2x plus 1, and I set that equal to 0. I add 3 here, and divide by 8. So 3/8 is one solution. Subtract 1 here. Divide by 2. It looks like what? -1/2. And I probably should check those, but because of time, I'm not going to. But if you take your calculator and multiply 16 times 3/8 squared plus 2 times 3/8 minus 3, you will get 0. All right. All right, the next problem says to solve using the square root property. Isn't it nice that they tell me what to use? So I'm certainly not going to FOIL this out and try to factor it or what. I'm not going to do that. So the square root property says I can take the square root of both sides. Now what I have to make sure and do is over here on the right is put a plus or minus. So do that first. Plus or minus is the square root of 47. So I take the square root of both sides. And when I take the square root of a square, I just get 3x minus 2. So when I take the square root of 3x minus 2 squared, I get 3x minus 2. But I have to put the plus or minus on the right-hand side, plus or minus the square root of 47. And I think 47 is prime, which means there are no perfect square factors in 47. So to solve for x, I just need to move the 2 to the right-hand side. And I move the 2 to the right-hand side by adding it to both sides. So that minus becomes a plus when I move it over to the right-hand side. And then to solve for x, I divide both sides by 3, and I divide everything on the right-hand side by 3. So x is 2 plus or minus the square root of 47 over 3. And just between you and me and the wall, I don't require you to simplify the radical. So even if you could simplify the radical, if you don't do that, I'll give you credit. So it's just not that big of a deal for me. And MyMathLab, I did verify, will accept 2 plus or minus the square root of 47, the whole thing over 3. It will accept that as your solution because I did this yesterday and it did. And we're halfway through, already halfway through our exam. All right, so the next problem, the next two problems are requiring you to use the quadratic formula. So one of them is going to have complex solutions. I guarantee you it will. So let's solve both of them using the quadratic formula. And I said one of the two problems on your exam that tell you to solve using the quadratic formula will be complex. All right, so let's find out. So what's my quadratic formula? Let me write that up here. Minus b plus or minus the square root of b squared minus 4 times a times c. All that's underneath the square root. The whole thing divided by 2 times a. So the only thing I really need to figure out what's a, b, and c are. So in this first problem, problem 9, there's a 1 in front of that x squared. So a is 1. There are no variables in a, b, and c. A, b, and c are constants. They're real numbers. B is the coefficient in front of the x, so that's 7. And c is my constant, 8. Okay, so let's make that substitution. So we get x is negative 7 plus or minus 7 squared minus 4 times a is 1 times c is 8 all over 2 times 1. Okay, so I get negative 7 plus or minus, take my handy dandy calculator out and calculate the square root, or excuse me, calculate 7 squared minus 4 times a. That's 49 minus 32. 49 minus 32, I believe, is 17. All over 2. And you're done. There's no simplification I can do. So that's the answer. And MyMathLab will accept negative 7 plus or minus the square root of 17, the whole thing divided by 2. So you're done. That was pretty easy. It was just a plug. No chug, just plug. Okay, let's do the next one. So a is 1. B is negative 4. And c is 20. So we have x equals minus a minus 4. Oops. Plus or minus the square root. And it doesn't matter 1 iota if b is negative or positive underneath that square root. Because as soon as I square b in that first term, it becomes positive. So it matters if you plug it in as a negative the first time you plug it in. When you plug it in underneath that square root, as soon as I plug in a negative or a positive and I square it, it's going to be positive. So negative 4 squared and 4 squared are both 16. Right? Minus 4 times a is 1 times c is 20. All right, the whole thing divided by 2 times 1. Okay, so I take my handy dandy calculator out and I take 4 squared and I subtract from it 4 times 20. 16 minus 80 is negative 64. So I have minus a minus 4, which is 4, plus or minus the square root of negative 64, the whole thing over 2. Okay, but what's the square root of negative 64? By definition, the square root of negative 64 is 8i. So we get 4 plus or minus 8i over 2. And that I can simplify because I can write this as 4 over 2. Woo! Plus or minus 8 over 2 I. 4 over 2 is 2. 8 over 2 is 4. So 2 plus or minus 4i. You get 2 solutions and they're conjugates of each other. Is that a coincidence? No, it isn't. We'll talk about that later. But you're going to get 2 solutions, 2 plus 4i and 2 minus 4i. And you can input this into MyMathLab as 2 plus or minus 4i. It's okay with that. So we would just type that into the box, 2 plus or minus 4i. The next question is a Pythagorean theorem question. The base of a 12-foot ladder. So here's my wall. Here's my ladder leaning up against my wall. And that's what you do when you have a ladder, right? You lean it up against the wall. And you know how long your ladder is. I would think you would know how long your ladder is. And my ladder is 12 feet long. And I know how far from the edge of the building, I know how far this base is from the wall. I know this is 3 feet. I mean, I know that. So I can figure out how high up the wall I can get. If I have a 12-foot ladder and it's 3 feet from the base of the building, I can figure out what this distance is. And that might be important. I might need to know if I can reach the second floor window. Okay, so how do I do that? I use the Pythagorean theorem. And the Pythagorean theorem says that the sum of the squares of the two legs of a right triangle is equal to the hypotenuse squared. So the 3 squared plus the, well, I don't know what that is. I don't know how high up the wall this goes, because that's what I'm looking for. X squared is equal to 12 squared. That's what the Pythagorean theorem says. So I have, my daughter just texted me and said the wind chill on Sunday is predicted to be minus 28. Dude, we're in Oklahoma. We're not supposed to get minus 28 wind chill. That's crazy. All right, anyway, where am I? So I get 9 plus x squared equals 12 squared is 144. I'm going to subtract 9 from both sides, and I get x squared is, what's 144 minus 9? 144 minus 9 is 135. So to find x, I can just take the square root of both sides, and I don't need the plus or minus because in this case, x is a positive number because that's how high up the wall my ladder is going to go. So x, let me write that up here. X is the square root of 135. Now, is there a perfect square factor in 135? I think there is. I think that is 9 times 15. And I'm okay if you leave it as the square root of 135 if you don't simplify it. My math lab will count it wrong, but I don't care. So that's 3 square root 15. That's the exact value. So this is what you would put in the first box. You'd either put 3 square root 15 or you'd put the square root of 135. Like I said, I'm fine with you not simplifying radicals. I'm okay with that. If it counts it, if my math lab counts it wrong, I count it wrong. I check every incorrect problem, every single solitary one of them. I first check for typos, if you put a comma instead of a period. And then I check your work. That's why if you want me to look at your work, I will go to your paper that you send me and I'll check your work. And if you type in the square root of 135 and my math lab wants 3 square root 15, I'll give you credit for that. Okay, then you take your calculator out and you find the square root of 135 and it says round to the nearest 10th. That is 1 decimal to the 1 number to the right of the decimal. That's a 10th. So you take this, you take the square root and you round it off to the 10th place, 11.6. So you know if you got a 12-foot ladder and it's 3 feet from the wall, you're going to go 11.5 feet up the wall, which may be where you need to go to replace that brick. I don't know what you're doing. Okay, the next problem is a radical equation. And this is actually the example we did in the class. I don't know how that happened. But to solve a radical equation, you need to isolate the radical and then square both sides. So you need to subtract 3 from both sides. Let's write this down here. This is exactly the same problem we did as an example in class. Who knew? Then you square both sides. When you square a square root, you get just the radicand. And then I'm going to square that binomial. And I squared it using the formula. You can FOIL it. I'm not going to walk you through that. Then I'm going to subtract x from both sides and 3 from both sides. And get this thing equal to 0 so I can factor it. So this factors to -6 and -1. So we get x minus 6 is 0 or x minus 1 is 0. X is 6 or 1. And 1 is not a solution. 1 is not a solution because if I plug 1 back in there, it doesn't work. 6 is a solution because if I plug in 6, that is going to work. So the solution set is 6, not 6 and 1, just 6. Okay? Because 1 doesn't work. The square root of 4 plus 3 is not equal to 1. So 1 is not a solution. So whenever you solve a radical, you see that where it says the second instruction, solve the radical equation, check all proposed solutions. They're not just telling you because they want to, they're telling you because you have to. All right, problem 13 is a rational exponent. And to solve a rational exponent, you need to isolate the x all by itself. So first thing we're going to do is get the 6 over to the right-hand side. And divide by 3. And then to solve for x, we need to get rid of the 9/8. And the way we do that is we raise both sides to the 8/9. Because when you raise a power to a power, you multiply the exponents. 9/8 times 8/9 is 1. And you're done. Because that is an acceptable answer. You don't need to write it any other way. So 2 to the 8/9 is the answer. Okay. Now, just to be mean, honestly, this is a pretty straightforward exam, except I got to be mean on one of them. I mean, you got to be mean on at least one. So I give you a linear inequality that contains fractions. So you could solve this leaving the fractions in there, but I don't want to. So I'm going to multiply both sides of my inequality by the least common denominator. So what are my two denominators? 4 and 5. So what's the smallest number that both 4 and 5 will go into? 20. So the least common denominator is 20. So I'm going to multiply everything by 20. So I'm going to multiply the first term by 20. I'm going to multiply the second term by 20. On the right-hand side of the inequality, I'm going to multiply the first term times 20. And I'm going to multiply the second term times 20. So I multiplied everything by 20, except that that's a 1, not a 2. Okay, so what happens when I multiply by the least common denominator? Well, the denominators cancel. 4 will go into 25 times, so I have 5x. 4 will go into 20 5 times, so I got minus 5. 5 will go into 20 4 times, so I get 4x plus 20. So now I just solve it like I would in an equation. I want to know how my phone rings when I'm on silent. I need to let it ring because it might be my doctor's office. Let it ring. Okay, so now to solve this, I'm going to subtract 4x from both sides. I'm going to go ahead and add 5 to both sides to save a little time. So I get x is less than or equal to 25. So that's all the numbers to the left of 25 on the number line. So that would be this graph, wouldn't it? Would that be all the numbers to the left of 25 on the number line? And how would we write that in interval notation? Would that be from negative infinity to 25 using a bracket? And we have a bracket because we have less than or equal to. So negative infinity to 25 with a bracket. Okay, then we have our two absolute value inequalities. So the first one is a less than type. And to solve a less than type absolute value inequality, we take the stuff on the inside of the absolute values and we put it between the negative and the positive constant. So for the distance to be less than 3, it has to be between -3 and +3, and then just solve the inequality. Divide everything by 2, and we get x is greater than 1 and less than 4. So in interval notation, that's all the numbers between 1 and 4. 1 and 4. And we use parentheses because we do not have equality. We have less than. So we don't use brackets. We're going to use parentheses. And then the greater than type, you solve this by taking the stuff on the inside of the absolute values and setting it less than the negative. You take the stuff on the inside of the absolute values and you set it greater than the positive. And then solve the two inequalities. So I get 3x is less than, is that -6? So x is less than -2. 3x is greater than 24, divide both sides by 3. X is greater than 8. So this is x is less than -2 or to the left of -2. So that's negative infinity to -2. X is greater than 8, that's to the right of 8. So that would be from 8 to infinity. And we're going to put a union between those. And when you start typing this in, if you'll go down at on the toolbar at the bottom, when you're in My Math Lab, there will be a toolbar and the U will be in your toolbar. So you would type the first interval and then go down there and pick the U from your toolbar and then type the second interval. So it's anything less than -2 or greater than 8 is the solution to this. And there's your test. You're all going to make 100. I'm confident. So this review, you can find it like a zillion different places in Blackboard. You can go to your assignments and there's a folder for exam reviews. You can go to the test page and there's a folder for exam reviews. So whatever is convenient for you, you can go into the chapter 1, and you can find the exam review in the course contents in chapter 1, wherever it's convenient for you to find it. Are there any questions? So this is due Thursday at noon. If you haven't done the review, number 1, it counts for a homework grade, so you need to do it anyway. And can you see what a great way this is to study for your exam? All right, well, if there are any questions, we'll see you back at 12:30. I included in your email that I sent out yesterday a link to the 12:30 class also. So if you open that email and click on the 12:30.
Are we doing?
Yeah, go ahead.
Are we doing Are we doing another review in class or are we going to 2.1?
We're going to start 2.1. It's easy. It's wordy, but it's easy. All right, any other questions?
Is it easier than,
I think 2.1 is easier than anything we've done so far. It's just wordy, lots of definitions in it.